Hi everyone, welcome to the lecture on nesting programming constructs. So like we mentioned in the textbook, this lecture isn't about learning any new material per se. It's just taking things that we've learned in previous chapters and combining them together to add even more power into our program. So we're looking at how we can combine if statements on if statements and loops on loops on loops, and how we would actually figure out what's going to be output by the computer and build up some of those examples ourselves. So we'll be doing both of those things in these exercise slides where we look at some programs and we figure out what they're outputting, and then we also use some nested constructs to build out some programs as well. So the very first exercise here, we're going to need to put on our computer hat and think like a computer. Since we're doing that, we know we need to start at the very top of the program to figure out what is going to be printed to console by these instructions. So at the very top here, we would read in these three different variables and the values associated with them. Those are just variable assignments. We can do that easy peasy. Once we get to line 6, we have our first if statement. And underneath that if statement, we have a block of code that we would execute that contains some nested if statements as well. So the first thing we do is on this if statement on line 6 is we check to see, is bandana equal to red? In this case, bandana is equal to red, so this would evaluate to true. And we pop in then to the very first line of that block of code that's associated with the if statement on line 6. That line of code just happens to be another if statement, and this if statement has a slightly shorter block of code that's associated with it from line 8 to 11. For this if statement, we check to see, does fur equal blue? In this case, it does not, so that is equal to false. And because it's false, we skip to the very end of that block of code and there's nothing left to do. So nothing actually gets printed to the console by this one. It's a bit of a tricky one, but it's something that happens often and something that we'll often do in our own code and create some errors that we would like to debug. Because when we're looking at this as a human, we can probably see that, oh, hey, if any of these things up here on the if statements are false, we're wanting it to print out that it was not the thief. But that's not what the computer is going to do. The computer doesn't know that context. It's not smart enough to think about things like that. So what we would actually have to do is either add in this else and print to every single if statement that we have. So we would be copying that code 3 times, or building up a combined condition that just has an and in between all of these separate conditions. And then we would just have those 2 different print statements there. So it's a bit of a tricky one, but it's a good one to know because it will probably come up when you're writing your own code. For exercise 2, again, we're going to be putting in on our computer hat, and we want to know what's written to the console by the following program. So the very first line the computer would see is it has this variable n, and it's getting assigned a value that the user will be inputting, but that the human knows is going to be an integer, so it tells the computer to do so. These, again, are still my most favorite commands to use because every time I use them in my brain, I'm like, silly computer, I am smarter than you. So I hope you get some of that joy too when you see them. Now in this case, we have a nested for loop. Nested for loops are very common in bioinformatics, and they are very tricky as well. So I will walk you through this one. We'll see one more example of a nested for loop, and then at the end, we'll see how we can use a nested for loop in our own code. So when we have a nested for loop, just like our if statement, this outer for loop is what's going to kick us off. And it's going to say for I in range n. So for sake of argument, let's assume that the user input a value of 2 for n. We'll just say it's n equals 2. When n is equal to 2, that means that range n command is actually going to output a value of 0 and 1. So we know that I can be a value of either 0 or 1, or so can j when we skip to that one next. For the very first time we see it, I will start off with being a value of 0. And then it's going to jump into that block of code that it has underneath that for loop, which just happens to contain another for loop. So in this case, because we're going to be moving to our next part of our for loop, which is the nested one inside, we then execute for j in range n. And j will start off with a value of 0. Within that, we're just printing a plus to the console. This bit here where it says end equals, and then just an empty string with nothing in, just means that it's not going to have a new line or like that enter key at the end of that print statement. So you'll have noticed often that when we use prints in Python, it will start a new line. Sometimes we don't want it to do that. So we can specify this optional parameter to that command to tell it effectively not to do that, which is quite nice. So down here, I'm going to pretend that this is the console. The very first time that happens, it's going to print a plus. Then, since we're at the bottom of the block of code for this inner for loop, it's going to go back up and execute the next iteration of that inner for loop. It won't skip to after that yet because it still needs to finish itself. So you ought to think of the computer of like, kind of like it's delegating a whole bunch of workers, and it's saying, once it hits this for loop, it says, okay, go do that and let me know when you're done. And it won't continue with what it was doing before until it knows this other piece here is done. So for the next iteration of that inner for loop, which is the one with J, I will still have a value of 0, but J will now have a value of 1, and then another plus will get printed onto the console. Now, since we are done with that for loop, we move to the next statement within that block of the outer for loop, because that still needs to finish before we restart the outer for loop. And all that's effectively doing is printing out an enter. So that's just saying, okay, start a new line. So that's just hitting that enter key effectively. Once we do that, we skip back all the way up here to our outer for loop, and we go to the next value that we can have for I. And so in that case, I would be equal to 1. The inner for loop gets restart, so J will be equal to 0. And we'll print out another plus, but on that new line that we have. We finish that block, so we skip back up to the inner for loop. We go for our next value of J. So I is still equal to 1, J would be equal to 1, and we print out another plus. That's all done. So we finished the last line of the outer for loop block, which is just an enter, and that's what gets printed to console. So if you tracked what was happening here, effectively our inner for loop was printing out the number of different columns that we have. So it was telling us how many times we would see that thing that we're printing in a specific row. And the outer for loop was controlling how many rows that we have. So oftentimes when we have nested loops like this, instead of using I and J, we'll often use call oops, now I'm being confusing. I didn't type that in the right spot. Okay, I'll just write over it. I'll write with this. This will be easier. So instead of J, we would do column there. And instead of I, we would do row. So the outer one is going to tell us how many rows we have. The inner one will tell us how many columns we have of whatever we're printing. That can be a really helpful way to remember if we're having to print like a square of something, how we can control those values, because spoiler for the next one, N and N, we don't have to use the same range for the inner and outer for loop. We can use different ones. So exercise 2B shows us exactly what would happen if we use different ones. So we're getting a value of N from the user and a value of M from the user. The value N is going to be used for I, which is our rows. And the value M is going to be used for J, which is our columns. So in this case, what we know will happen here is we're going to get a box of pluses that contains N rows of M pluses. So if we gave, say, N is a value of 2 and M is a value of 3, what this would actually look like is plus, 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 plus. And if you don't believe me, write it up in your PyCharm and try it out yourself. You can trace through it in a little bit more detail like we did with the other one. Convince yourself that is actually what's happening. Keep track of those variables for the different iterations of those loops, and you'll see that's what you can get. All right, now we're going to move on to some programming exercises. So we have exercise 3A here, where we're going to write an algorithm that will count the number of cytosines in a given sequence using a loop. And then we'll also do 3B at the same time, well, like shortly after. I just don't want to flip back into the slides for that since it takes a bit of time. We're going to write an algorithm to report an error if a given sequence contains any non-nucleotide bases in it. So we'll start with 3A and we'll just flip over to PyCharm here. I'm so happy I got this fixed so that I can actually see PyCharm again. And I've already made my program here. So all I did was right click on my workspace, new Python file, and then I gave it the name chapter 11 exercise 3. And what we're going to be doing here is, scroll on my other sheet. We want to count the number of C's in a sequence. And that is for A. Let me just do that. So the very first thing that we're going to need, oh, why did I make that cue? Ignore me. The very first thing we're going to need is a variable that actually contains a sequence. And for the sake of this exercise, let's just hard code a sequence value into it. When we say hard code, that means we're just giving it a literal value. So in this case, we'll give it a literal string value that will just contain a number of A's and T's and C's and etc. In this case, the important thing to remember is exactly how many C's that you put in it. So in this case, I expect my output to be 5. And so you'll see I'm using a lot of comments here to help give context into any human reader that would come into this code so they would know A, what it's doing, and maybe B, some of the expected outputs. For the next part of my code, it's literally, we're going to be counting the number of C's. So for each nucleotide, if it is a C, increase the counter by 1. So this is just plain language, exactly what I want my code to do. It might look really similar to pieces of code. That's because Python also leverages some plain language syntax to help make code more readable. But that's really the comment I gave there is context for any human that came in to understand what this next chunk of code would do. Now, since I've been in this game a while, I know the very first thing I'm going to need to do here is actually define my counter. So I need to do that outside of any kind of loop or if statement that we're going to be doing to make sure that it's visible to the computer for all of those different things. So the very first thing here, I'll make a counter. I'm just going to call it num C, and I'll set that to be a value of 0. And then at the end, we know we need to print that out. So let's just print that out and make sure that this is working as we expect. As our programs get more complicated, I highly recommend that as you're building them up, when you're adding a little bit of new functionality, you just quickly run the program to make sure that it's working as expected. If you get an error, it's a lot easier to know, hey, it was like the last 3-ish lines of code that caused an error, and you can jump back in there and try to figure out what the bug is. So if we run this, we expect to see a value of 0 on the console, and in fact we do. So we know that this is working as expected. So now we need to loop through every single nucleotide in our sequence. And conveniently, we can use a for loop to help us do that. So remember, a for loop can loop through every character within a string. All we would need to do is say for nucleotide in... I wanted to just call that nuke because I don't want to spell out nucleotide every time, but that's okay. For nucleotide in seq, I'm just going to have it print the nucleotide to make sure that that for loop is working correctly. So again, this might feel like it's taking a little longer, likely is because I'm explaining things, but if you're doing this just as you go, it helps you build up confidence that your program is working correctly. So I'd expect to see each of these different letters printed on its own line, followed by a 0. And if we run this, that is exactly what we see. So we see our for loop is correctly grabbing each nucleotide every iteration of that loop and just displaying it to console. Since I know that's working, I can just comment that out because it's not actually needed in order to solve the problem at hand. But what we do need is an if statement to check to see if the nucleotide is a C. So we just have that if nucleotide equal the string of a capital C. Then we're going to increase num_c by 1. And remember how we do that is just saying num_c equals num_c plus 1. So that's just taking the value of num_c currently and adding 1 to it. And if I run this, this should work as expected to give us our value of 5. Hooray! Now we have part B, which is where we were printing an error if a sequence contained a non-nucleotide. You'll see I got all these squiggles and lines and whatever from PyCharm. It's because I forgot to put a comment sign in front of it, so it thinks that it's code. That was just for me to know that, hey, we're on to our next piece here. I'm going to leave it in the same code so that we can use this good sequence to also test it. But then we can also have a second sequence variable where we add in a whole bunch of good nucleotides and then maybe throw in a random couple of variable or a couple of characters that aren't nucleotides so that that should actually produce an error. So what we actually need to do in order to do this is for each nucleotide, if it isn't A, T, C, or G, print an error. So we don't need a counter variable or anything like that for this one. So we can just dive right in to that for loop. And again, we can use the exact same style of for loop that we used above on line 8 there. We can even reuse that same variable name because it was only valid for this chunk of code that was up here. Computer has since forgot about it. We can now reuse it, override it if we want. You can also call them different things though, which I honestly would recommend doing. Helps keep things easy to understand if you're getting a certain error from a variable when they're different names. So in this case, let's use seek2 because that will give us the behavior of actually displaying an error. And then we want to check to see if nucleotide is not equal to A or nucleotide not equal, etc., etc. This is quite long. I'm going to teach you a trick. You can do it this other way. That's completely fine. Another thing we can do is we can actually use that in command that we had up here to check to see if the current letter we have is in some other sequence that we want to define. So, and in this case, we're thinking of sequence in terms of a computer science sequence. So that's like a string, a list, a range that we got, that kind of thing. So a valid nucleotide in this case would be A, T, C, or G. So this will check to see, is that nucleotide one of those four letters? And if we want it to not be one of those four letters, so we want to flip it, all we have to do is add that not right before that in command, and it will actually flip it for us. So it's a quite nice way of getting that behavior that we're looking for without having to type out that really, really long condition. And so if that is the case, we want it to print error. It should print error for seek2. So if we run this, we should see our 5, and then we see, oh, so many errors. Why do we see 2 errors? Why do we see 2 errors? This is what I know why. Because we have 2 non-nucleotides in here. That almost really threw me for a loop. If we try just regular sequence, we just get the 5, which is behaving as we would expect. That really almost got my brain on this lovely Sunday morning when I'm recording this. But that's all good. All right. So the last exercise we have here is we want to produce a right triangle with a given height that consists of plus signs. So very similar to the code that we had here, where we only we were inputting different numbers for different rows and different columns, or even this one here where we're using the same for the rows and the columns. But we just want to change that code a little bit so that if we're on row 1, it's only going to print out 1 plus. If we're on row 2, it's only going to print out 2 pluses, and so on and so on. I would actually challenge y'all to do this on your own and test yourself. How is it going with that knowledge of nested programming? If you're having problems, come to help hours, come to labs, reach out on the course discussion board, etc., etc. See if you can get your triangle printed correctly. There is a solution posted, obviously, underneath where you got these lecture slides, but try to get this going on your own. It is tricky, but if you can do this, everything else will seem simple. I promise. At least when it comes to nesting. All right, happy coding, and we'll talk to y'all later.